Hello, this is the fourth video in the Roots series of OCR Pure Core AS Further Maths. It will look at forming equations with related roots by substitution. This slide is a reminder of the transformations or stretch linked to finding equations with roots that are a multiple of other equations. You may want to pause to relate this to any matrix work and function transformation topics. In effect, a red graph is a stretch parallel to the axis of scale factor 2. This can be achieved by using the mapping of, in effect, halving x, so f of x mapping onto f of half of x. In previous sessions, we looked at working out a new equation by considering the sum and pairwise products or products of roots. Here's another method for deriving a new equation using substitution, based on what we've noticed about the graph relationships. Using the substitution x equals u over 2, we can either use this, or if you find that too confusing, just think of it as a mapping of x into becoming x over 2 instead. Using this substitution, y then becomes 2 u over 2 cubed minus 5 u over 2 squared minus u over 2 plus 6. We want to take out the brackets, being careful to square everything inside the brackets. We get to this. And then simplifying those fractions, for the first one anyway, then to that. If we then prefer a to be as a coefficient of x cubed to be 1, we could multiply through by 4 to get an equation u cubed minus 5u squared minus 2u plus 24. We would probably then write this new equation using x again. X cubed minus 5x squared minus 2x plus 24 equals 0. As I mentioned before, if you don't like using this idea of substitution, you can just replace x in effect with a mapping of x over 2, and then you would just have x in all of these workings instead. And just to remind you, this is now an equation with roots 2 alpha, 2 beta and 2 gamma. Let's consider another cubic equation. In this case, we can see that coefficients are a equals 1, b equals 4, c equals minus 2, and d equals minus 6 for the original equation, whose roots are alpha, beta and gamma. We want to find an equation with roots 3 alpha plus 1, 3 beta plus 1, and 3 gamma plus 1. You may want to pause the video here to think about what substitution you might use. If you use the substitution u equals 3x plus 1, then x will be replaced by u minus 1 over 3. Or if you prefer not to use u at all, just think about it mapping onto x minus 1 over 3. Using the substitution, we would have u minus 1 over 3 cubed plus 4 u minus 1 over 3 squared minus 2 u minus 1 over 3 minus 6, which, if I use either binomial or Pascal's triangle to expand, would give me u cubed minus 3 u squared plus 3u plus 1 all over 27 plus 4 over 9 u squared minus 2u plus 1 minus 2/3 of u minus 1 minus 6. For ease, I'm going to multiply by 27 to get rid of those fractions. When I've done that and then gathered the like terms together, I would have u cubed plus 9u squared minus 39u minus 133. As you can see on this slide, the u has then been replaced back by an x to give the equation in its normal form: x cubed plus 9x squared minus 39x minus 133 equals 0. So this is the equation with roots 3 alpha plus 1, 3 beta plus 1 and 3 gamma plus 1. In the next session, 1.5, we will connect the work on roots of equations with the complex number topic in solving polynomials with complex roots.